All right, more physics fun. This one's going to be on forces and vectors, free body diagrams. So there are some multiple different types of forces. So tension force is when we have rope, string, cable, etc. Example like a elevator, a yo-yo, pendulum, tetherball, that kind of thing. Then we have the normal force, which is contact surface force. Very important that you understand it's a contact when two surfaces come in contact with one another, perpendicular to the contact surface. And then the applied force is a push or pull anything on an object. Friction force is whatever is opposing motion, and the incline force is a resultant of the normal force in mg. So if you add normal force in mg, you get an incline force, which is equal to mg times sine theta. Sliding down, any object sliding down an incline at a constant velocity, then the coefficient of friction, kinetic friction, would be tangent theta. So mu is the coefficient of friction. In this case, we've got a box here that's being pulled or being pushed. Pushed to the left. Friction force is acting to the right. And as long as the box is moving at a constant speed, there's no net horizontal force. That means the applied force equals the friction force. So remember that. Constant velocity means applied force equals friction force. So also, if the box is on a flat surface, the mg for the box, or the weight of the box, is equal to the normal force of the box. So that's to say the net force in the vertical direction is 0 as well. But just in case you wanted to calculate that for any angle, the normal force is always equal to mg cosine theta on the surface. So whatever theta is, right, in the event where theta is 0, flat surface, then normal force equals mg. All right, so coefficient of friction is friction force over normal force. So sliding on a flat surface using mu sub k, mg mu sub k equals friction. That's the idea that the normal force is equal to mg on a flat surface. So multiplying both sides by the normal, mg mu sub k is equal to friction. Okay, in this case, net forces. So we got several net forces to consider. Net force is for vertical. If we're looking at the vertical net force, that's to say force up minus force down equals the vertical net force. Horizontally, net force, force right minus force left. Incline net force, force down the incline minus force up the incline. And then remember, if the net force is 0, then the F up equals down, left equals right, up the incline equals down the incline. Okay, and this is what I call a Newton's second law apparatus, where we have a mass hanging over the side of a table, pulling another mass along the top of the table. This is the applied force, which is also equal to the tension force, which is also equal to mg of the hanger. So that applied force is equal to mg here. Notice that the applied force is being applied by mg, but then the acceleration is of the system. So the applied force would be little mg, and that would be equal to big M plus little m, parentheses, times A for the system. So the whole system would accelerate together, and it would not accelerate at the rate of g. So then friction force is mg mu, right? So normal force is equal to mg. Now if we have that same box sliding here, we're looking at mg is the hypotenuse, the incline force is mg sine theta, normal force is mg cosine theta. This is theta, this angle, same as this angle. All right, have fun.